Now let's look at some of the other API methods that are designed to push data to the database. That's the put, post, and delete methods created by the template. This is definitely more interesting than just pulling data back, but we're only going to work with author objects. You've seen that there are a lot of complexities to consider with persisting related data with EF Core, and I don't think that complication is necessary for this fundamentals course. If we're running these methods, we can't just call them in a browser because we have to send along their REST verbs, put, post, or delete, and in addition to possibly adding scalar data in the URI, like we did for getting authors by ID, you might need to also pass data as request bodies through the request header. If you want to learn more about the details of RESTful APIs, this slide comes from Sean Wildermuth's Designing RESTful Web APIs course. I don't want to write a whole front end for this API just to demonstrate these methods, and this is where Swagger can help us out. If you haven't used Swagger before, just follow my lead. I will only focus on the parts that are relevant to the task at hand, so it shouldn't be too challenging. I've changed the default URL for the HTTP launch settings profile back to Swagger. And the first thing I want to do is add a new author, which is tied to the map post method. The template-generated method expected an author to be passed in. We still need to add an author to the database, but remember that the goal is to pass the author DTO into and out of these endpoints. So the first change is that the author parameter should be an author DTO type. And I want to explicitly name that author DTO for clarity. But I can't add that to the author's DB set, so I need to create an author object from the properties of the passed in DTO. And code completion was so helpful here. The next two lines are as they were originally created from the code gen. They add the new author to the author's DB set and call save changes. And as always, save changes will push the newly generated ID back into the author object. The endpoint was originally returning that author, but again, we want to return a DTO. So I'll create a DTO from the author data, including that newly generated author ID. Like the other responses we saw, this one is returning an HTTP typed result. This time it's created, which aligns with the HTTP 201 code. The first parameter of that result will go into the response header, and the second, the author DTO, will become the JSON result. I'll go ahead and get the API running, and here's Swagger showing us all the methods. Clicking on the bar for post will expand its details, and then we'll go directly to the Try It Out button. There are two types of information to send to REST calls. Parameters, which are scalar values, like the author ID I passed to the get method, and or a request body, which gets passed through the request header. For the post method, we need to send an author DTO object, so that will be through the request body. The Swagger UI has inferred this from the controller method. And notice it says no parameters in the parameters section, but the expected request body is the author DTO. This is another example of the benefit of using the DTO. If this were expecting an author object, you wouldn't be prevented from sending a fully fleshed out object with books and covers and artists, but by using the DTO, I can only send exactly what my code needs. Keep in mind that I'm still working against the sample database, but this is exactly the data that will get passed in, first name string and last name string. And I don't mind because it's just my development database, but you can certainly change the name of the database in appsettings.json if you prefer. And this is the object that will get passed into the post method, which will catch at the breakpoint in the code. Because this is an insert, it doesn't really make sense to have the author ID in there, and you could take the app design a step further and create a DTO specifically for inserting and updating authors that doesn't include the ID. But I'm just going to ignore that author ID. So I'll hit execute, and the author DTO object has the values 0, string, and string that we just sent in. I'll let this method complete, and then taking a quick look at the database, there's the new row in the authors table with the first name and last name both string, and the new ID is 13. We looked quickly at the put method earlier. This one accepts an ID, and that's the ID of the author to edit. And originally from the template, the second parameter was an author, which I've changed to author DTO. And remember, this uses the execute update async method to push the changes into the database. Oddly, the template is trying to update the key value, author ID. So that's a big no, and I don't know why the template does that, but I'm going to just comment out that line. For the other two, I changed it to use the properties of the author DTO that was passed in, and now it's ready to roll. I'll stick a breakpoint on the first line of code, and then let's go back to Swagger. I'll expand the put method this time so we can edit that new author. Again, I'll go right to the Try It Out button. This time, Swagger detected that the put method needs that integer as a parameter and an author DTO as the request body. Once again, I'm just going to ignore that author ID. And I know that my execute update command is going to ignore it as well. I know that I want to edit the author with ID 13. And instead of my author being named string, I'll change it to Sarah Penner and then click execute. Now here I am back in the code at the breakpoint. I can see the incoming ID is 13, and in the author DTO, the ID is 0 because I left it that way, and first name is Sarah, last name Penner. After the execute update async, the code then verifies that one row was affected, and if so, returns an OK code. If not, it returns a not found code. And then checking back in the database, author number 13 is now Sarah Penner. One more method to go, the delete method. And this one did not require any modifications to deal with a DTO instead of the author, because all it takes in is the ID of the author, and all it returns is an HTTP response. So as I pointed out earlier, it uses the execute delete async method to send a delete command with the incoming ID to the database, and then returns the relevant result code again. So I'll go back to Swagger, and this time I'll try out the delete method. And it knows that it only needs that integer parameter for the query string, not a body. I'll enter 13 as the parameter, then execute, and back in the database you can see author number 13 is now gone. And remember, we still have those logs, so looking quickly at that in the console window, there's the delete call to the database. Well, I hope this gave you a great head start on using EF Core in ASP.NET Core apps. While I thought that building the app was fun, I also think that one of the most important lessons here was understanding how the life cycle of a web app impacted EF Core's change tracking, and the importance of using short-lived contexts, asynchronous calls to the database, and non-tracking queries to save time and resources. After the controller was added to the app, you learn about using ASP.NET Core's built-in dependency injection to let the app spin up a new pub context as needed. And you didn't even need to be a DI expert to pull that off. And thanks to the built-in logger, you saw that it's not necessary to add all that logging code into the DB context that we had to for the console app. And that ASP.NET Core outputs its logs to a bunch of different places by default, and you can always configure it to behave differently. For example, we added some logging configuration to the app settings JSON file. While the endpoint template does create a really good stake in the ground to get you started, you can always use your own experience to improve on those methods, or just design controllers to perform other work based on your business needs. And we did do an important refactoring so that we have some important separation of concerns between the controller's interaction with the client and interaction with EF Core in the database. In the next module, we'll focus on testing your applications that are using Entity Framework Core. And along the way, we'll do an important refactoring that not only will make our application more testable, but it will also make our applications have much better design. I've referenced a lot of different resources in this module, including a number of Pluralsight courses. Here are 2 pages of collected links for you.